my students. Today we are going to study two very important protocols of wireless LAN, the MACA and MACAW. So we will discuss these two LAN protocols which are known as MACA and MACAW. MACA is the oldest protocol of these two protocols. MACA was proposed as an alternative to CSMA protocol, which has certain drawbacks. We have studied already the CSMA protocol, and if you see the video, you will find out that we have discussed the drawbacks of CSMA, that is carrier sense multiple access. Now, first, it senses the channel to see if the channel is free. And if the channel is free, it transmits a packet. Otherwise, it waits for a random amount of time. Now, this is what happens in a CSMA. But the problems here are, the problems of the CSMA protocol are the hidden station problem leading to frequent collisions, the exposed station problems leading to worse bandwidth utilization. Now the hidden station problem and the exposed station problem also we have studied. So I will provide a link of these two videos, that is one of the CSMA protocol and other of the hidden station and exposed station video in this in the description box of this particular video. So now you know that the CSMA protocol has these two basic problems. One is the hidden station problem, which leads to frequent collisions, and the exposed station problems, which leads to underutilization or worst bandwidth utilization. So MACA eliminates the hidden station and the exposed station problem by using RTS. What is RTS? RTS stands for repeat to send. And CTR. What is CTR? Clear to send handshake mechanism. So MACA basically uses a mechanism that is known as the handshake mechanism, and it uses the RTS, that is repeat to send, and clear to send, which is CTR. So we will discuss RTS and CTR in detail, CTS in detail. CTS stands for clear to send and RTS stands for repeat to send. Okay. So RTS and CTS, these are the two mechanisms which are used for handshaking, or these are the two handshake mechanisms which are used in the MACA protocol. So the RTS and CTS packets carry the expected duration of data transmission, which will have some implications. So all nodes near the sender and receiver, after hearing RTS and CTS, will defer the transmission. That is, for a while they will stop the transmission. Now, that means they will avoid transmission for that particular duration of time when they hear RTS and CTS. Therefore, it avoids some cases of hidden and exposed station problem. Now, immediately after hearing the RTS and CTS, as the sender and receiver, as the nodes near the sender and receiver defer the transmission, so it avoids the cases of hidden and exposed station problem, which was the major problem with the CSMA protocol. However, it does not always avoid these problems. To some extent, it can avoid the hidden station and exposed station problems, but it does not guarantee to avoid them always. If the neighbor hears the RTS only, and if it does not hear the CTS, so if it is free to transmit once the waiting interval is over. So basically, if the neighbor, that means the neighboring nodes of the sending and receiving nodes, hear the RTS only, so then if they are free to transmit once the waiting interval is over. So with the help of this diagram, we can see the node C is within the range of node A, and vice versa. That means we can say that node A and C are within the transmission range of each other, and node B and D are within the transmission range of each other. Now node A sends an RTS to node B. That means node A is sending RTS to B. Now then, as you know, C and A are within the transmission range of each other and B and D are within the transmission range of each other. After receiving an RTS from node A, node B sends a CTS to node A. Then the actual data transmission between node A and node B takes place. So this is the MACA protocol, that for any two nodes to begin transmission, the node which wants to send will send an RTS to the node which it wants to transmit, and the node which is on the receiving end will send a CTS to the transmitting node, and then the actual data transmission will take place. Now just assume that there are 4 nodes named as A, B, C and D in a wireless LAN. A is the sender and B is the receiver. The station C is within the range of A, that we have already seen in the diagram, but not within the range of B. Therefore, it can hear transmission from A, that is, it can hear RTS from A, but not transmission from B, that is, CTS cannot be heard from B, just what we saw in the figure right now. Therefore, it must remain silent enough for CTS to be transmitted back to A without conflict. So, unless B sends the CTS back to A, for that duration of time, C must remain silent. The station D is within the range of B but not A, so it hears CTS but not RTS. Therefore, it must remain silent during the upcoming data transmission, whose length it can tell by examining the CTS frame. Then the node B sends CTS to A and then follows data between A and B. Just what we saw in the figure right now. This is what we saw, and this has been explained. So that means when B sends CTS to A, then actual data transmission follows. Now see, here's the RTS from node A but not the CTS from node B. As long as it does not interfere with the CTS, it's free to transmit while the data is being sent. In contrast, the station D is within the range of B but not in A, that we have already seen. That station D is within the range of B but not in the range of A. So, station D does not hear the RTS but it does hear the CTS, because B is sending the CTS and it is in the range of station B. So, hearing the CTS tips it off that it is close to a station that is about to receive a frame. So, it defers sending anything until that frame is expected to be finished. Now, despite the precautions, collisions still can occur. As I just told you in the beginning only, that it avoids collisions to a large extent, but still collisions are not completely avoidable. For example, station B and C can both send RTS frames to A at the same time. So these frames will collide and will be lost. It is quite obvious. And in the event of collision, an unsuccessful transmitter, which is the unsuccessful transmitter? The one that does not hear a CTS within the expected time interval, waits a random amount of time and then tries again later. Now let's look at MACAW. Basically, MACAW stands for MACA for wireless. So this extends MACA to improve its performance, which will have the following handshaking mechanism. So what is the handshaking mechanism which is used in MACA? There is an RTS which is sent, then a CTS is sent back. The sender basically sends the RTS, receiver sends the CTS. After that, the DS is sent, then the data is sent, which is the actual data, and then an acknowledgement is sent. So, here we will explain this through a diagram. So, A sends an RTS to B and B sends a CTS to A. A sends an RTS to B and B sends a CTS to A. Then A sends a data sending message to B. DS stands for data sending message, that it is about to send the data. Then B sends the data to A. Then B sends the acknowledgement to A, right? So I will repeat it once again. A sends RTS to B, B sends CTS to A. Then A sends data sending messages. DS stand for data sending messages, and after receiving the DS or data sending messages, B sends the data to A, and then A sends the data to, then A sends the DS to B, then A sends the data to B, and then after receiving the data, B sends the acknowledgement to A, right? So the station which wants to send will send these RTS. The station which has to receive will send the CTS. Then before transmitting the actual data, the sending station will send the DS message to the receiving station. Then the sending station will send the actual data to the sending station, and then to the receiving station, and then the receiving station, after receiving the data, will send an acknowledgement to the transmitting or sending station. So this is the MACAW protocol. That means MACA for the wireless networks. So basically we can say that MACAW extends MACA with the following features. So what are these features? The first feature is data link clear acknowledgement. So without the data link layer acknowledgements, lost frames were not retransmitted until the transport layer noticed their absences, which was much later. MACAW solved this problem. How? By introducing an acknowledgement or an ACK frame after each successful transmission. So here you see that after each successful data transmission from the sender to the receiver sends back an acknowledgement, and whenever an acknowledgement is not received, the sender knows that the data frame has not been received. Then the second feature is addition of carrier sensing. So CSMA has some use, namely to keep a station from transmitting RTS, while at the same time another nearby station is also doing so to the same destination. So carrier sensing was added in MACAW. Third point is an improved back-off algorithm. MACAW runs the back-off algorithm separately for each data stream. That is, what is the data stream? It is the source destination pair. Every source and destination pair is known as the data stream. So basically MACAW runs the back-off algorithm separately for each data stream rather than for each station. So instead of for an individual station, it runs the back-off algorithm for the source destination pair, and this source destination pair is known as the data stream. So this change improves the fairness of the protocol, because both the stations are waiting for an equal random amount of time. Now next is your DS. The last additional feature is the DS, which is the data sending message. Now if a neighbor of the sender overhears an RTS but not a CTS from a receiver, in this case it can tell if a RTS CTS was successful or not. When it overhears a DS, which is the data sending message, it realizes that the RTS CTS was successful and defers its own transmission. So basically any neighboring station on hearing the DS knows that the RTS CTS was successful, because only when the RTS CTS was successful the DS was sent. So even if it did not hear a CTS, but if it hears a DS, it presumes or it knows that the RTS CTS was successful, and therefore it defers its own transmission. So this is all about the MACA and MACAW protocol.